All right, we're going to keep going with similar triangles, and we're going to do a few different scenarios, different ways you might see things, and learn a few more theorems, and hopefully all this proportional, similar stuff will start to click for you and be making sense. First theorem we're going to write down or look at is if two triangles are similar, then the lengths of their altitudes, that's their height. So if two triangles are similar, then the lengths of their altitudes are proportional to the lengths of the corresponding sides. So this is the altitude, right? That's the height, the altitude. So what that says is the lengths of the altitudes are proportional to the lengths of the sides. So AD over FJ, those are the altitudes, equal, and you can pick any of the sides, it doesn't matter. So I'm going to pick AC over FH. And that's if the two triangles are already similar. That means all the sides are proportional, so the heights are also going to be proportional. All right, if two triangles are similar, then the measure of the corresponding angle bisectors. So that means if you have an angle bisector, like this, each of these, the measures of those two are proportional to the length of corresponding sides. So LP over RT, or it could be RT over LP, either way, is proportional to QS over, oh, that's not right, KM over QS. Not so bad, right? Just says that if you have an angle bisector, the length of it is proportional to the sides. Okay, if two triangles are similar, then the lengths of their medians. Remember, a median goes from an angle to the opposite midpoint. So from an angle to the opposite midpoint. So if there's a median, they're also proportional. So CD over ZY, right? Could be ZY over CD, doesn't matter. So the medians are proportional to the length of their corresponding sides. So we'll go with AB over WX. Okay, and our last one says the angle bisector of a triangle separates the opposite sides. So angle bisector of a triangle separates the opposite side into two segments that are proportional to their corresponding sides. So here are the two segments, right? The opposite sides separated into two segments that are proportional. So Km over ML is proportional to their corresponding sides. So JK over JL. All right. Take a little, do a couple of quick examples. Maybe. Is there one down here? Oh. All right, we're going to do a quick example. So we have triangle ABC is similar to triangle FDG. So all of the sides are proportional to each other and all of the angles are congruent to each other. So real quickly, find the value of x. Well, x is angle bisector. And our theorem said that the angle bisectors were proportional to the corresponding sides. So x over 8, x is from the larger triangle, is proportional to 15 from the larger triangle over 12. So we cross multiply, get 12x equals 120, divide by 12, and we get x equals 10. And that's believable because 10, if this is 10, is bigger than 8, and 15 is bigger than 12. So that's a reasonable answer. All right, the next few, we're not even going to solve them. We're just going to set them up, okay? Because I know that you can solve these. I'm not going to waste your time in a video watching me solve proportions. So here we have an altitude. I know it's an altitude because it's perpendicular. So remember, we said the altitudes are proportional to the corresponding sides. So 16 over x equals 20 over 15. Cross multiply and divide. All right, here we have two triangles that are similar. These are medians. They go from an angle to the opposite midpoint, right? So the medians from the angle to the opposite midpoint are proportional. So 13.5 over 9 are proportional to the sides. So 13.5 is the bigger triangle, x is from the bigger triangle, 3 is from the smaller triangle. Cross multiply, find out what x equals. All right, here we have an angle bisector. It said that if you have an angle bisector, the two segments it creates, so there's x, and this one is 20 minus x, right? I don't know how long it is. I know the whole thing's 20. So x over 20 minus x is proportional to, and now x came from this triangle, so it's going to be 14. 20 minus x came from this triangle, so it's over 11. Cross multiply, find out what x is. And our last one, have the same scenario. We have an angle bisector. We have opposite sides. So 4 over 6 is proportional to x over 13. Small over big, small over big. Cross multiply and divide, and that's that. So finish those out and be ready to work on it tomorrow.